I'm now going to explain what is a bimetallic strip and how does it work. Now, basically the word bimetallic tells you that the word bi means that there are two pieces of metal and they are in a strip form, so longish. So all bimetallic strips consist of two different metals, right? If the metals are the same, then you cannot call it a bimetallic strip. So in this example, we have a piece of brass and a piece of iron. And in the previous pages, you will learn that to join two pieces of metal together, you will use rivets. Okay, so now the two pieces of metal are very close together. Now, the thing about bimetallic strip is that when you heat up a bimetallic strip or you cool down a bimetallic strip, you will see that the strip is going to bend. Okay, and what you then need to know is you must know which way does it bend. For example, this bimetallic strip, if I heat it up, is it going to bend this way or this way? So how do we tell? Well, so since we mentioned that the bimetallic strip is always made out of two pieces of metal, there will be one metal that will expand more than the other. And the metal that expands more than the other will also be the same metal that will contract more than the other metal when you cool it down. So let's say, for example, I have a bimetallic strip like that. So I call this metal A, and it is joined to metal B. And say, for example, A is the metal that will expand more when you heat up. Of course, when you heat up, both metals will expand. But let's say A is the metal that's going to expand more than B. So if the two metals are not joined together, then you would expect that, I just draw something that's a little more exaggerated. So you would expect that if they are not joined together, A may be something like that, you know, and then B also longer than before, but maybe not as much, something like that. But because they are joined together, so you cannot allow this to happen, right? So if they expand, because they are joined, so what's going to happen is that they must form a shape that allow A to be longer than B, and at the same time still allowing both metals to join together. So what's going to happen is you will see something that looks like this. So B may be somewhere here. Okay, so this is B and this is A. Now, when they bend in this manner, you would, if you look at it closely, you will see that A actually is longer compared to B. And one way to find out, you know, which metal is longer is you imagine that this is a running track. Okay, so let's say when you go to the stadium, or rather the school track, and then if you do a running, I'm sure if you're given a choice which lane you want to run, you'll probably want to run on the inner lane, right? Because we know that this is shorter. The outer lane is going to be longer. So therefore, if you look at this, just imagine this is part of a running track. So the one, you know, roughly imagine to be the outer lane is going to be the one that is longer. So A is now longer than B. So if the bimetallic strip bend in this way, it will allow A to become longer than B. Now, what's going to happen is if I were to cool down this bimetallic strip, so this is what happens when you heat it up. All right, so let's take a look at what happens when you cool it down. So again, the same bimetallic strip. So this is B, this is A. Now, remember I said that the metal that expands more when you heat it up is the same metal that will also contract more when you cool it down. So just now when I heat it up, A is the one that expands more. So now if I were to cool it down, A will be the one that will contract more when you cool it down. This will contract, but this will contract more than this. So you would expect that the bending will be such that A will be the one that's shorter than B after the bending. So how can you make that happen? if let's say this is, oh, sorry, they should be about the same height as before, the same thickness I mean. So this is A, this is B. Alright, so from here to here, when you cool it down, can you see? Now A is on the inner lane. So A is now the shorter metal compared to B. So when you cool it down, this is how the bimetallic strip is going to bend. Now understanding this, let's go back to the slides. So in this example, they use brass and iron. Now brass is the metal that expands more. So this is the one that when you heat it up, it's going to become longer, so it expands more. And that's the reason why when you heat up, this is when it's heated. Can you see? This is brass. And brass is the one that is longer. Okay, so brass is actually longer compared to iron. Of course, both of them will be longer than before you heat up, but this is going to be even longer compared to iron. And what's going to happen is if you were to cool it down, so when cooled, so both metals are going to contract, and brass, so this is brass is going to contract more compared to iron. So now it bends upwards because now brass is going to be the metal that is shorter. So now if you look here, this is like the inner lane of a running track, right? So this is actually shorter. So it is important for you for this chapter that if we were to give you a bimetallic strip and we tell you which metal expands or contracts more when heated or cool, you must be able to draw for me which way it bends. So let's take a look at some examples. I'm going to skip the thermostat. Anyway, this is how a real bimetallic strip looks like. I'm going to skip the thermostat. It will be in another video. But I want to go on to practice question 4a. So in this case, they say that A expands more than B. So A is the metal which is not shaded. So this is A and this is B. So how will it look like? So remember, if A expands more, A will become longer than B. And so the bending will look something like this. So this will be B. Alright, so this will be B, this will be A. Because A expands more, so A has to be longer. So this is the way it will bend. So it will bend like a rainbow. Okay, it bends downwards like a rainbow. What about this? If you heat up and it's vertical, same thing. This is A, and we would expect A to be longer. So then the longer one will have to be on the outer track, right? So same thing. So it will look something like this. Sorry, my drawing can be a bit neater, but I think you get the idea, right? So this is A. So it's like bending like a letter C, you know. So this is like a letter C. This one is like a rainbow. So now A is longer. So now let's take a look at this. Now again, A expands more than B when heated, but the question is asking for cooling. Well, if A expands more than B, then A will also contract more than B when you cool it down. Okay, so A will also be the one that will contract more. So now, sorry, this should be changed before cooling and after cooling. So before cooling, this is how it looks like. So after cooling, you would expect A to be the shorter metal. So the way you have to draw may be something like that. It takes a bit of practice. Okay, so but follow the same order like what you see here, because like the shaded one is at the bottom, so keep it at the bottom. So now this is A, because A is now shorter than B, so this is the way it bends. So now the bending is like upwards, like a smiley face. And what about this one? This one is before you cool down. Again, after you cool, A should be the shorter metal. So then, just now you have a letter C, right? So now it's not letter C anymore. This will still be A. And now A is on the inner, right? So this is again shorter than B, which is what we would expect. Okay, so this one will bend something like that. So this is how you will do questions on bimetallic strip. But like I say, because I'm just doing a draft, so the diagram may not look very nice, the thickness may not be even. When you have more time and when you're doing it with a pencil, I think you can actually draw it a little nicer. Okay, so the next video I will talk about the application of bimetallic strip, and we'll come to that later.